So when we have a normal distribution, it's when data that has been graphed as a histogram or frequency polygon results in what we call a unimodal symmetric distribution about a mean. That's a big word there. Okay. What it really means is it looks like a bell curve. And so if we go back to our example that we looked here, this frequency polygon kind of has a nice curve to it. And in math, we call that a bell curve. And so I'm going to draw it out here on the graph here. If we were to kind of make a histogram or a frequency polygon, and it looked something like this here. And now I'm probably going to butcher it because, yeah, for sure I did. Let's try that again here. Always go up way too quick there, but okay, so it looks something like that. There we go. Okay, and that is going to be around a very specific point. It's going to be right about the mean. Okay, so this is going to be our mean right here. And now my graph isn't overly great. There's a lot of work that I could do on it and try to make it a bit better. But you'll notice here that our graph, okay, or that frequency polygon is around the mean, or what we would consider to be mu. Okay, so it's around mu, it's around our mean. So if our mean is right here, we're going to have a bunch of data points on this side, a bunch of data points on this side. Should be, we have about half the data points on one side and half the points on the other side. That should be as well. That's if we have something really nice. Our properties of normal distribution, so something that looks like this, is that the graph is symmetrical. So not like this, but if we actually drew it out nicely, it would be symmetrical. Mine's a little bit of a hack job based on the tools that I have right now. And if I had a pen and a paper, it would probably be almost as bad. My graphs tend to be a little bit rough. So if the graph is symmetrical, it's going to mean that our mean, median, and our mode are usually quite close to equal, or very, very close to it, and they fall around the line of symmetry. So they're going to fall right around here in our graph. So if we were to have taken the mean, median, mode from Phil's golf scores, the mean would have probably been right close to the middle of this here, right about, let's say this would be about 70.5. Okay, they should have been pretty close to that. Now, I haven't actually gone through and checked that, but it looks like it would probably be there because that looks pretty normally distributed. Our curve is going to be bell-shaped, looks like this here. Okay, here's another good example. Phil scores, that's pretty bell-shaped. Okay, that's pretty close to bell-shaped. It's actually really good. Where it peaks in the middle here, and then it slopes down to the sides on both sides. Never actually gets to zero. It gets very close, but it never gets actually right to zero. And the last thing there is that our area underneath here, which the area represents all the data points, 100% of the data points are going to fit inside of this area. And so that's our cue there. All the data should fit underneath this area. There shouldn't be any that are above, which means that, so if we looked at this graph right here, you'll notice that, yeah, the edges are out, but there's some room on the inside to fill in. We don't have any of these pieces, which are like way above. Okay, so let's say this one right here, it's not like way above. Let me just modify that. Okay, it's not like that. This would be way above. No, it's not there. It's in kind of in this graph. So all of our data points are in the graph if we put it in there. Now, what we call this is something called the normal curve. And the normal curve is a symmetrical curve that represents our normal distribution. We also call it the bell curve. And all of our data fits inside of here. And a certain percentage is going to fit in each area if we see something as being normal. Okay. If the data is classified as normal, we can use this following curve to interpret and analyze the data. What it's going to be, so this is going to be our histogram, just drawn out a little bit smoother. Okay? It means that in each of these kind of sections, we have a certain percentage of the data. So here's our mean, and think of these as our boxes. Think of these as our intervals. In this interval right here, okay, from this line to this line, we're going to have 34% of our data. And that's what is going to be based on normal. If it is normal, we're going to have 34% of our data. If we have, in this box right here, 13.5% of our data would be there. Here, 2.35%. And then at the ends, there is just a little bit as well, and it's usually not drawn on there. But at the ends, we also have 0.15% of our data, and that's going to be on either side. So this is also going to be 0.15% of the data is going to fit into that little box right there. Okay? And this box actually is kind of everything else. It's not superset size-wise. This is everything above this point. This is everything below this point. So these boxes, we can understand what percentage of the data is going to fit in there. Now, on the bottom here, we have mu and we have sigma. Okay, remember, mu is our mean and sigma is our standard deviation. So this box right here is actually the range from our mean to 1 standard deviation above the mean. Okay, 1 standard deviation above the mean. And so what that means is that this box right, if we were to create a frequency table for this, we would have 8 boxes, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and those boxes would be represented by the mean and the standard deviation. Okay, it would all be represented by the mean and the standard deviation. Okay, so that's what it's saying here. Now, if we look between 1 standard deviation and one below the mean and one above, so these 2 boxes, that's going to be 68% of the population. If we go 1 more standard deviation away, so from 2 below to 2 above, that's 95% of the population. And if we go from 3 below to 3 above, that's 99.7% of the population. Okay, so this is representing how much of the population or how much of the data fits inside of these certain categories. I often use the example of height. Height is pretty normally distributed, both males and females are. What it's telling us here is that the majority of people are going to be roughly average height. Okay, that's the majority. And then as we get into these taller heights, there's going to be a less amount of people that are taller, and these shorter heights, there's going to be less amount of people that are shorter. Only a very small percentage of people are actually going to be like way above this value or way below this value. Okay, so that's the extremes. There's very few people that are actually in those areas, or very few data points, if we want to consider it that are within that area. I use the example of our school. If we were to collect all of the students in the school, there would be about 5 students that would fit in this side and this side combined. So think of it, there's about 2.5 people that would be way above the norm and way below the norm. So that just represents kind of how few data points are actually there. Okay, about 2.5 people would fit there. That's a very, very, very small percentage of people that would fit into those sections. So this curve here represents normal, and we can use this curve to understand how many data points or people fit into a certain range and based on a set of population.